Okay, this is just a short entrance to this video. The last video, the battery died, and I was getting ready to explain some stuff that'll carry on. I spliced it onto this video. It kind of picked up where right before it cut out. In this video, we have the Q meter is finished, completed. But I said in the last video that I would wind a coil with it and show you how that worked. But the battery died, and so this video is just simply added on to past the point where the battery died. The next video after this, I'll pick up and go on with getting coils wound for the one-band shortwave receiver. Sorry about if you expected there to be a coil winding episode in this video, but we'll get to it. I promise. But go ahead and watch this video if you want, and it's got some fun information that I've discovered while I was looking around for some other circuits, and I'll just let it go from there. Thank you for watching, and enjoy this video. Where we're headed with this, in case you just joined, we're going to start off. Here's the schematic. This is a one-band shortwave receiver with an audio section. It uses a 6V6. It uses a 12AX7 as an audio preamp. It has a BFO. A 6AH6 BFO. That's for you to receive sideband and or CW signals, so that you can put a beat note against a CW note. Or if it's sideband, you can zero beat them on right on top of them, and it'll detect their audio. It has RF amp, a 6AU6 RF amp. Get that in frame. And the mixer local oscillator is a 6BE6. And then it has 2 stages of IF with the 455 kC IF cans on both sides. So what we're going to do when we come back, we're going to find and make the coil for the antenna input coil. And we'll probably also have time to make the coil for the plate circuit of the RF amp. Those are where we're headed next. Okay, now the neat little thing I was going to show you. This is trick. I found this in the manual of a R392 URR. It's a military receiver. Goes from, I think, 0.5 megahertz all the way up to I believe 32 megahertz. But the neat thing is it runs on 28 volts. I was looking at the tube that it used in there, and it uses a 26D6. That's a 26 Delta 6. And so I went and looked up a 26D6 just to see what it was, if there was anything close to it. In the data sheet, it said that all curves follow for a 6BE6. So me having 12 volts right here at my disposal, I got a bus bar in here, it goes right out to a 12 volt battery. I chose to go ahead and use a 12BE6 and check this little guy out to see if he'd work. Real simple. Little 25 volt transformer. That's the power supply. It's a 25 volt transformer. Just a full wave bridge. About 800 microfarad of capacitance to filter it. And that's all it's needed. And here's the little tube. Yeah, 28 volt. my voltmeter actually measured 30, I think it was 30.6. 30.6. Let me grab the frequency counter here. We'll hook this up real quick again. Have my little sample cap already on this one because I was looking at it the night. I was really, this is neat. 30 volts, plate voltage. Don't need any high voltage. And all I did is I copied the circuit as it was out of the manual. I'll show you there's a couple things I did need to do just to make it work. I substituted a resistor and a choke for one of the coils. I put a choke in here instead of I didn't have the transformer. This is the 455 kCIF transformer. I just simply took this out, put a choke in it so that I could read the frequency here with the frequency counter. That would let me know if the tube was running. And over here on this end, where there would have been a coil in the antenna hooking in that little cap, I just simply put a 10K to ground, because this is where another signal would have come in, and it mixes with its local oscillator. The cathode, control grid, and first screen form a little triode, basically, with triode circuit, a Hartley oscillator circuit. And it would have mixed with the antenna signal, and your output would have been 455 kc away from the tuned, from what the oscillator's running at. So I just substituted those just to make it work, just to try it. So let me get my frequency counter fired up here. Find the power cord to, oh, got it upside down. That ain't gonna work. You won't be able to see it. Okay, so here comes the power supply, 30 volts. Now we gotta have, wait a minute, I'm getting ahead of myself. I need a jumper lead for 12 volts. So let me grab that. Find the filament pin. Alright, there's 12 volts to the filament. What else do we need? Oh, we need a ground. Another ground. Alright, I can borrow a ground. Alright, there we go. Now, where'd my power cord go? Okay. There it is, up and running. 3.52 megahertz. The bottom of the CW band. And see, I have a little trimmer cap. See, I can raise that. See the frequency going up. Slick as can be. That's a 12BE6 in a Hartley oscillator circuit running at 28 volts. Now, if you'd like a schematic that I've got so far, I'm going to make some more experiments, and I've got to figure out if I can get an RF amp to work at 12 volts, or 30 volts, I mean, 28 actually. And just quickly, let me set this aside, kind of, so I can show you what these schematics look like. This was on, let's see, what page? Page 63. of the R392 URR manual. I think I downloaded it from, let's see, where was it? Boat Anchor Manual Archive, BAMA. Boat Anchor Manual Archive is where I found the TM. I've got it, let's see, my notes here. It's TM 11-858. TM 11-858. The theory explanation starts on chapter 4, page 44, and it explains every part of that receiver, how the tubes work, how the circuits work, and the schematic. I'm going to show it to you right here. This is page 63. This is the circuit that I got this circuit from. Like I say, I just simply changed a couple things. See, they show pin 7 is just disappearing, and it goes to the plate of another mixer tube. So I just took that to ground. 28 volt here comes in through the first IF can, and I didn't have that IF can, so like I said, I just put a little 250 microhenry choke. Yeah, 250 microhenry choke in place of that. But this should be able to use a standard tube type 455 KCIF can, like out of one of the 5-tube table radios. The receiver parts that I'm using are going to come from CB radios. The particular CB radios are the Johnson line, a Johnson Messenger 1, Johnson Messenger 2, and a Johnson 223. Okay. The fun and joys of dealing with batteries that die before you're ready for them to. Okay. I was explaining about the parts that I'm going to be using for, and I bet I didn't have it over here. Otherwise you'll wonder what in the world this video is all about. There it is. Okay. This is just a look ahead at this shortwave receiver that we're going to be building from parts from CB radios. I was explaining from the last video when it quit, the parts are going to come from the Johnson line of, see, let me move my viewfinder here to make sure I'm in frame. Anyhow, they're going to come from the Johnson line of radios, mainly the Johnson 1, Johnson Messenger 2. They're called out the 2, it's the black-faced Johnson, and the white-faced Johnson was the Johnson 1. There was a Messenger 202 that was a business band. I never even knew about it back in the 60s, that business band radio even existed. It wasn't until I went to a swap meet here a couple years ago that I found one on a table, and they were asking only $10 for it. So I grabbed it. I recognized it as the black-faced Johnson, but it just didn't have all the right knobs. Got it home, found out that it was a business band. It was like a 20-watt Johnson 202 business band, a single channel, didn't even have a channel selector on it. You just had the one channel transmit and receive, and all it had is on-off volume and squelch. Quite the rig. But it has all the parts I need. So if you see one of those, grab it. Because it'll have the IF cans. You're going to have the tubes that you need. The power transformer, that's very important because those things are almost $60, $70. It won't have the OA2, that you'll have to find off of eBay. A couple of these tubes you might have to find off of eBay. But, and I used an audio circuit that uses a 6V6. I didn't like the circuit that was with the original schematic on the radio. I tried to play just a kind of a, not even a test for high fidelity, but I wanted to play some music through it. That was my test to see if it would work and sound good. Sounded terrible with music. So I thought, well, that'll never work. It's distorted, it's tinny, it's scratchy sounding. So I went through several different iterations, and finally I found a 6V6 guitar amp that had the correct input, used a 12AX7 as a preamp, first and second stage, and a driver, and the 6V6. The next task I had to find was the audio output transformer, since the original transformer in the Johnson would not match up with the 6V6. It ended up that I found a 70 volt to line matching transformer. There's some examples of those still on the eBay. When I get down to it, I'll show you the transformer I used. They have like several taps. I think they have a 16 ohm and an 8 ohm tap, and then they have on the primary, it's a from 0. They have like a half a watt, 1 watt, 4 watt, 5 and 10. And those taps are what you end up using for your primary. And you just choose either the 8 or the 4 ohm, I think it's, yeah, 4 or 8 for the speaker. This circuit does use one of the legs for some negative feedback, which I liked. That actually made the circuit quite clean, and it really cleaned the audio up when it used negative feedback. So it's a neat little circuit. And when we get ready to do this, I can provide more information. If you want the schematic, as it is right now, it's not complete as far as some of the coil values. That's what we're getting ready to do with this little circuit that we just built. But they're JPEG. You just send me an email. I'll put my email address up at the end of the video here, and just shoot me an email and I'll send you the JPEG. Just ask for receiver schematics. And if you want all of them we've done so far, just put the word all schematics receiver, and I think there's about 7 or 8 of them. They're JPEGs. They're small. They don't take up a lot of room. I can email them to you. All right, I was talking about that manual in this little circuit that I built in the last video right there. This is the circuit as it's drawn in that manual on page 63. It's what is known as a permeability tuned oscillator. It's a Hartley oscillator circuit. In other words, they don't have a variable capacitor to tune the frequency. They use the core. That's why there's a little dashed line here that shows that the core is movable. And it's just like a 3/4 inch bar of ferrite, and it moves in and out of the coil. Their physical properties of that is 10 turns moves the oscillator 1 megacycle. Is how they've got that figured out. And this circuit runs at 28 volts. The tube here that they show in the circuit is a 26D6, 26 delta 6, and I used a 12BE6, and it worked. It oscillated. That was in the last video. So now what I've got to do is I've got to experiment with this one. They're using a 6AJ5 as a crystal oscillator, and I may use that tube for like an RF amp. They do show 26A6 as an RF amp. This is between the antenna and your mixer circuits. There's maybe a little bit bigger drawing there. 26A6 is the tube, and I'm going to try to see what other tube will work in there and still run on 28 or 30 volts plate voltage. The first IF amp is also using a 26A6. It'd be kind of neat if this would actually work with a 6CB6 or a 6AU6. Yeah, that's what I'm going to experiment with. So those of you that want to try and do this with 28 volts, you can have a whole radio that would run off of 28 volts. I think that would be pretty cool. And they had the BFO in the radio, and it uses a 26A6. The BFO runs at 455 kcs. I've already built a circuit similar to this, so I have the coil dimensions, and I think I used it. I made an 80 meter receiver, and then I built a BFO, and I think I used a 6BA6 for that one. 6BA6. But anyhow, that's kind of the fun part of this kind of a side thing that I'll try to do, and I'll provide information as I get it, and I'll make note and let you know that I have some schematics available. The little circuit I already got going, tossed it out of the way here, but let me grab it. That's this little thing. It's on this test board, so I could figure out the coil and the tube. It's using a 12BE6, and let me get back to what right here. That's the schematic that worked. Last video you seen this. So I know that a 12BE6 will work at 28 volts. Proved it. So now we just got to see if it'll convert and how well it does with that. And that's the next thing. When I get some time, I'll experiment with that, and I'll let you know my progress on that. Okay, I'll just make this a short video. My battery ran out on me on the last one, so I'll put this one up. This video will just be a second one added instead of adding it on to the last one. So if you want any of those schematics, shoot me an email, and I'll send you the whatever schematics you want. And you might just put receiver schematics. If you want the 28 volt stuff, you get on the list. I'll start making a list of the people that are interested in that, and every time I get a new circuit, what I can do is just automatically email you whatever new information I come up with, and the schematic, and like whatever tube I found that would work. I will start with the RF amp and work from the antenna towards the speaker, so to speak. Alright, thanks guys. Have a fine one, and we'll get back to that little Q meter. That's this guy, and we'll get making some coils. That's what this is all about. We need to find out what our antenna coils. I'm going to wind them for probably 80 meter band was where I'll start. And this will be the first step to getting the antenna coils, grid and plate antenna coils for the first RF amplifier in the shortwave receiver. Okay, thank you. See you in the next video.